keynote speech 始めたいと思います。Let's start day one keynote speech. ジェームス・ショアさん。わー。どう私の動線がどうなってるんだって。はい、OK。ジェームスさん is a very famous book writer and agile practitioner, right? Yeah. From XP, right? Yes. ここ英語の部屋なんで英語で喋らなきゃですね。he wrote the 今ブック署名が飛んだ。Art of Agile Development. So that is so nice book. That book published in 2010 in Japanese edition, I think. So I wrote several times, and that is great book to start the new team and a new join. First day, how can I do it? That is great guidebook for the start of agile development. The team or the society, I think, organization. Thank you so much. So, and also I joined several training or the workshop in the agile conferences. Yeah, that's so nice. He's a great practitioner, I think. ということで、今日はお話を聞きたいと思います。Let's start the keynote speech. Is that okay? Sorry. Thank you. I'll use this mic. Thank you.
Test.
Okay.
How are you measuring productivity? It was September 2023, and my CEO was asking me a question. How are you measuring productivity? It was September 2023, my CEO was asking me a question, and my position as Vice President of Engineering was less than 3 months old. How are you measuring productivity? It was September 2023, my CEO was asking me a question, my position was less than 3 months old, and I didn't have an answer. So I told the truth. How am I measuring productivity? I'm not. Productivity can't be measured. It's true. The question of measuring productivity is a famous one, and the best minds in the industry have concluded it can't be done. Martin Fowler wrote an article in 2003 titled Cannot Measure Productivity. Kent Beck and Jerzy Orzosz, apologies if I'm pronouncing that name wrong, revisited the question 20 years later. Kent Beck concluded, measure developer productivity? Not possible. My favorite discussion of the topic is Robert Austin's measuring and managing performance in organizations. He says a measurement-based approach generates relatively weak improvements and significant distortion of incentives. How do I measure productivity? It can't be done. At least not without creating a lot of dysfunctional behaviors. But this isn't a talk about measuring productivity. This is a talk about what you do as Vice President of Engineering when somebody asks for the impossible. How are you measuring productivity? I'm not. It can't be done. You're wrong. I don't believe you. It was September 2023. My position was less than 3 months old, and it didn't look like I was going to make it to the end of month 4. Luckily, my CEO is a fairly reasonable person. Our company is fully remote, so he invited me to come to his house next time I was in his city, so we could discuss it face to face. This gave me a month to cool off and think about what I wanted to say, because I had said some things that you're not supposed to say to your CEO. I had an impossible, or at least dangerous, request: measure productivity. Given that I couldn't give my CEO what he wanted without creating dysfunction in engineering, what could I give him? And that's what this talk is really about. The CEO, Chief Product Officer, Chief Technical Officer, and I met a month later. I said, if we had the best product engineering organization in the world, what would it look like? I walked them through an exercise right there on the CEO's dining room table. It had a lot of index cards and sticky notes, of course. In the end, we came up with 6 categories. Imagine we're the best product engineering organization in the world. What does that look like? I don't know about you, but I would rather have the best product engineering organization in the world than measuring productivity. For us, we decided it meant these 6 things. First, if we had the best product engineering organization in the world, we would have the best people in the business, and we would be the best place for them to work. They'd beg to work for us, and people who left would try to replicate their experience with us at their new company. Second, we would have high internal quality. Our software would be easy to modify and maintain, and we'd have no bugs and no downtime. Third, lovability. Our customers, users, and internal customers would love our products. We'd excel at understanding what stakeholders truly need and put our efforts where it mattered the most. Fourth, visibility. Our internal stakeholders would trust our decisions. Not because we'd be perfect, but because we'd go out of our way to keep them involved and informed. Fifth, agility. We'd be entrepreneurial, scrappy, hungry. We'd actively search out new opportunities and change direction to take advantage of them. And then finally, profitability. We would be the engine of a profitable and growing business. We'd work with our internal stakeholders to ensure our products were ready for the real world of sales, marketing, content, partners, accounting, and every other aspect of our business. Are we the best product engineering in the world today? No. Will we ever be? Probably not. But we don't need to be. If you did this this isn't literally about being the best product engineering organization in the world. It's about constantly striving to improve. These 6 categories are the ways we want to improve. What does this mean for you? If you did this exercise with your CEO, you would get different answers. I'm not saying that our categories are the best for everyone, but it is still an interesting thought exercise. We are an organization that's steeped in agile thinking. I have been in the agile community since 2000. As mentioned, I wrote a book. The 2nd edition is out now. These 6 categories may not be exactly what your organization would use, but these 6, people, quality, lovability, visibility, agility, profitability, these are worth investing in. So I'm going to talk about what we're doing in each of these 6 categories. And if you're a senior manager, some of what I mentioned may be useful to you. If you're not a senior manager, then these are techniques that you can potentially take to your managers. Agile only succeeds if your organization is truly behind the ideas and principles of Agile. And you can share these ideas as examples of what other people are doing. Let's dig in. Everybody wants the best people in the business, but our company is relatively small. We can't compete with the likes of Google, Amazon, Apple, the FAANG companies. They're looking for the best people too, and they have way more money than we do. But we can still get the best people in the business. And that's because we define best differently than they do. They're looking for people who went to prestigious schools, who have worked for other FAANG companies, who can solve LEET code problems in their sleep. We don't want those people. We're an inverted organization. That means that tactical decisions are made by people doing the work, not managers. In theory, we're not perfect. So we're looking for people who have peer leadership skills, who are great at teamwork, who will take ownership and make decisions on their own. And we're an extreme programming shop. We use XP as our model of how to develop software. And as it turns out, XPers love teamwork, peer leadership, and ownership. They also love test-driven development, pairing, continuous integration, evolutionary design. They tend to be passionate, senior developers. And they're dying to be part of an XP team again. You see, extreme programming is too extreme for most companies. Just like real Agile and real Scrum is too extreme for most companies. How many times have you seen Scrum used as an excuse for micromanagement? Or a senior leader tell you that you have to be Agile and give them a detailed plan for exactly what you're going to do over the next year? In other words, there aren't many companies who are using XP. There are a lot of great people who wish they could use XP. And so we have our pick of top quality candidates. And as a fully remote company, we have a lot of flexibility in where we hire. Now, I said we're an XP shop, but that's not exactly true. Our founders were immersed in extreme programming, and XP is where we want to return, but there was a period of time where the company grew quickly and lost that XP culture. We have a bunch of engineers who don't have the XP mindset, and we need to bring them on board too. This is a matter of changing organizational culture, and organizational culture isn't easy to change. Our engineering managers are at the forefront of this effort. To help them along, we've revised our career ladder. This is the document that describes what you need to do in order to be promoted at our company. The old career ladder emphasized understanding advanced technologies and building complex systems. The new one emphasizes teamwork, peer leadership, ownership, and XP engineering skills such as test-driven development, refactoring, and simple design. This is what it looks like. It's a big spreadsheet which describes each title in our engineering organization along with skills required to reach that title. For example, associate software engineers are hired fresh out of university. They're only expected to have classroom engineering skills. They contribute to the team with the help of other team members. Mid-level software engineers are expected to be able to contribute to the team without explicit guidance. We expect them to have basic communication, leadership, product, implementation, design, and operation skills. And senior software engineers are expected to have the advanced versions of those skills. Technical leads are expected to mentor and exercise peer leadership, and so forth. As I said, each level defines a set of skills. For example, associate software engineers are expected to be fluent at the skills in classroom engineering, which includes object-oriented programming, following direction as part of a pair, basic debugging skills, and basic function and variable abstraction. Mid-level software engineers are expected to be fluent at basic communication, which includes skills such as working collaboratively with other team members, disagreeing constructively, building on other people's ideas, and so forth. There are a lot more details than I can explain here today, but you can use this QR code here to find a detailed article, including documentation that we use for each of the skills. Today, what I'd like to do is highlight a few skills that I think are particularly important. First, communication and teamwork. Before I joined, work was assigned to individual engineers. They would go off and work for a week or two and then come back with a finished result. And actually, this is common at a lot of companies that I see. Before I joined this company, I was a consultant for 23 years, and I worked with a lot of different companies, seeing a lot of different types of behavior. And what we have at this company is actually fairly similar to what I see elsewhere. So as I said, people would go off and work and then come back with a finished result. Now, rather than assigning work to individual engineers, we're assigning it to teams. I'll talk more about how teams are defined later. So we expect those teams to take a valuable increment, go off and work on it together, including collaborating with product management and stakeholders to understand what's really needed, and to take responsibility for figuring out how to work together as a team. And this has been a big cultural shift. It's uncomfortable for some folks. To help change the engineering culture, we've defined a lot of skills around communication and teamwork, and this is just one example. So a new engineer is expected to participate actively in team conversations. And then, as they grow, they're expected not only to share their perspectives, but to actively work to understand other people's perspectives as well. As they grow further into a senior role on the team, they're expected to pay attention to who is participating and who isn't, and make sure there's room for everyone to speak and be heard. And ultimately, as the team's most senior engineer, they're expected to actively work with management to create an environment where people feel safe speaking up, speaking their mind, and expressing disagreement. So as a reminder, what I'm trying to do here is change the engineering culture at my organization. One of the ways I think the engineering culture needs to change is to have more teamwork and less individual work. And this latter of growing expectations and responsibility is one of the ways I'm encouraging these changes. Let me show you another example. If we want to delegate decisions to people doing the work, and we do, then peer leadership skills are essential. Peer leadership is the ability for everyone on the team to take a leadership role at appropriate times according to their skills and the needs of the team, regardless of titles. We have many leadership skills, but one path starts with our most junior engineers with a skill called follow the process. But this isn't just about following the process we've set out. It's also about working with the rest of the team to adjust the process or make exceptions when the process isn't a good fit for the situation. As engineers grow, they start to take on explicit leadership roles. One of those roles is team steward. Each team has a team steward who is responsible for defining how the team works together and keeping things on track, keeping everyone aligned. This is a role we expect our engineers to take on early in their careers to start building their leadership muscles. But senior engineers are expected to have a more nuanced and fluid understanding of leadership. They're supposed to understand that leadership isn't about who is in charge, who formally has a title, but instead about reacting to what the situation needs and following the lead of the people who have the most knowledge about the situation at hand. They're expected to identify and follow the people who are best suited to lead in any given situation and to build their own ability to do so, regardless of formal leadership roles. And then our most senior leaders, engineering leaders, take this one step further. They work with managers to understand the leadership skills of everybody on the team and understand which skills are missing and help develop the team to build those missing skills and to build on the strengths that they have. This is a big spreadsheet. There's a lot in there. Similarly to leadership, if we're going to delegate decisions to team contributors, we call them team contributors, not individual contributors, then we need them to take ownership of creating great results. And one of those paths starts with intrinsic motivation. The idea that engineers are motivated by the joy of engineering and working with a great team. We don't want people who have to be constantly told by their managers, hey, you should work on this thing. We want people who put in their best effort because they truly love the work. Now, that doesn't mean that all the work we do is always fun. And before people can advance out of a junior role, they have to have the maturity to take on unpleasant tasks that exist on every team. And in English, this is called scut work. It's the tedious, disagreeable chores that have to be done. Scut work isn't something that only junior engineers do. It's something everyone has to do. And what we're looking for is the ability to take it on without being asked. We're looking for the ability to recognize and take responsibility for things that need to be done, even if they aren't the most fun. Every engineer participates in the team's retrospectives, but to be a senior engineer, they have to do more than participate. They have to take ownership of making improvements. Our senior engineers are constantly identifying and proposing tweaks to improve how teams work together and how they interact with people outside the team. At least that's what we would like it to be. We're not there yet. And our most senior engineers should take that one step further, identifying impediments to the team's success that are outside of the team's control and working with management and other leads to remove them. Last one, I promise. There's more, but this is all I'm going to do today. We also put a lot of emphasis on XP skills, extreme programming skills, and particularly on simplifying our design. And this is one example. Junior engineers are expected to know how to use functions and variables to make code more readable. As they grow into mid-level engineers, they learn how to refactor those functions and variables to improve abstractions, and they also learn how to create appropriate class abstractions. Senior engineers know how to refactor those class abstractions, and they use those skills to simplify the design of the system. It's common for an initial design to be overly complicated, so it's important for people to be paying attention to how to make things simpler over time. This emphasis on simple design is the opposite of what I've seen in some companies. In some companies, the more senior you are, the more complicated your designs are expected to be. But we do the opposite. We think complexity is easy, and it's simplicity that's hard. So we expect our most senior engineers to produce simpler designs. And then finally, our most senior engineers understand how to refactor the system as a whole and how to prioritize those refactorings according to the risks and costs of change. So to recap, our career ladder is a tool for cultural change. We're using it to move from an organization that prized individual work, advanced technologies, and complex systems to one that focuses on teamwork, peer leadership, ownership, and simplicity. We launched the career ladder in June of last year, so just about 6 months ago, and it seems to be working. My managers tell me that they're seeing shifts in behavior with people volunteering to lead meetings and take on work that they didn't before. We're also been able to use the new career ladder as a touchstone for people who need help with their performance. Of course, the career ladder isn't enough on its own. It helps people understand what's expected of them, but it doesn't do any good if people don't know how to perform those skills. So to help out, we're supporting the career ladder with the career ladder changes with an extreme programming coaching team. Every open headcount I've gotten since I joined the company has gone towards hiring very senior XP coaches. These are player coaches who get hands-on with the code and lead by example. They work alongside the rest of the engineers, demonstrating as part of the team's normal day-to-day work how XP works and why it's such a great way to work. We are at a ratio of about 1 XP coach for every 11 engineers. And that's not quite enough yet. But it is enough that we can start developing coaches internally rather than hiring externally, which is important. And of course, as additional positions open up, I will be hiring more people who already have XP skills, although not necessarily at the same level of seniority. When I look at how other companies approach this problem, the main thing I see is a lack of commitment. They'll have an agile center of excellence or something similar, but the ratio will be closer to 1 coach for every 50 to 100 engineers. Those coaches often aren't engineers, so they can't lead by example. And even when they are engineers, they are spread way too thin at 1 to 50 or 1 to 100 to work side by side with the other engineers. The best way to learn XP is to be immersed in it, day in, day out, on your real-world work. You need a coach working alongside you as you learn. And with ratios of 1 to 50 or worse, there's just no way for that to happen. You can learn the project management aspect of Agile, but you can't learn the technical skills which are vital to be successful. So as I said, we have a ratio of 1 to 11 XP coaches to engineers, and I would like it to be closer to be 1 to 6. Our initial coaching hires are jump-starting that path, and we're going to be training people internally. As everybody advances along this career ladder, our senior engineers and our technical leads will be the ones who will be providing a lot of that coaching, and then our staff engineers, who are the XP coaches I've hired from the outside, will be training them and moving from team to team. People are the lifeblood of any organization. And they're particularly important in an agile organization where so many decisions are made by the team contributors, not the managers. So if we were the best product engineering organization in the world, we'd have the best people in the business, and we'd be the best place for them to work. To get there, we're defining best differently than most companies. We're looking for teamwork, peer leadership, ownership. We're attracting people who love extreme programming and emphasizing simple, clean designs rather than algorithms and complex solutions. And we're changing our company culture with a new career path and player coaches who lead by example. I don't speak Japanese, but I do have a favorite Japanese word, muda. I learned about muda from the Toyota production system. Muda is my biggest problem, and it's the biggest problem at many companies I know. And let me give you an example. This graph is going to show 5 months of engineering work on a product. It isn't going to be real data for confidentiality reasons, but it is based on my real-world experiences. On the x-axis, we have months of data. And on the y-axis, we're going to have the amount of time that people spent on various types of work. So over these 5 months, this example team spent about 35% of their time on deferred maintenance. They had a key technology that they hadn't kept up to date, and the vendor was dropping support, so they had no choice but to stop everything else to work on replacing it. They spent about 25% of their time on call and responding to production incidents. They spent about 5% of their time on routine maintenance. They spent about 20% of their time fixing bugs. And only about 15% of their time on doing things that added new value to their business. Let me put it another way. If this fictional organization had spent $1 million on development during this time, only $150,000 would have been spent on things that business partners really valued. The other $850,000 would have been wasted. It was necessary, but not valuable. Muda. And that is why muda is my favorite Japanese word, because it is the thing that we need us all to fix. So why is there so much muda? I see 3 common problems, again, in my company, but also the many companies I've worked with over the years. Complexity, slow feedback loops, and deferred maintenance. These are often lumped together as technical debt or legacy code, but each is its own problem. So let's take a closer look at each one. Complexity is the result of having lots of different systems. It's hard for any one developer to understand how everything works, so they have to work very slowly and carefully, and even then you still get bugs and production incidents. Our systems don't have to be that complicated. In the rush to deliver features, people chose complicated technologies because they promised fast results. And this has been repeated many times over the years. Each technology requires a bunch of expertise to understand and use. And so it's become impossible for any one person to understand how everything fits together. It's also become difficult to make these tools exactly what we want to do, and it's hard to make them work nicely. So we have nobody who is an expert in everything. This is a fundamental mistake I see a lot of companies making. When they think about how to deliver a feature, they focus on how much it will cost to build that feature. They don't think about how much it's going to cost to maintain the feature. So they choose solutions that are easy to build but hard to maintain, but the majority of software costs are maintenance costs. They're not build costs. And neglecting maintenance costs puts them and us in a difficult position. It's 2025, and so we can't talk about development costs without also talking about AI. And don't get me wrong, AI is a great tool, and I use it for all the images in this talk. Apologies to those of you who dislike Gen AI images. But it allowed me to add character and interest that I could not otherwise add. Remember this image, though? Let's take a look at this guy in the middle. Did you wonder why he has a coffee cup on his head? That's because he has an eyeball in his hair. Or how about this character? He's hiding a third hand. My point is that these tools are never going to be as good as the people selling them want you to believe. And there are some true believers out there. I know them. They will get better, but I don't think they're ever going to be perfect. The problems with image generation are fairly obvious. You can tell when somebody has an eyeball in his hair or an extra hand, although I'll admit it took me a while to notice. I didn't look that closely. The problems with AI in code are more subtle, and they come down to that trade-off between speed of building and speed of and cost of maintenance. You can build code very quickly with AI, but getting it all to work together nicely is harder. If you're using AI to write code in your company, are you considering how you're going to maintain that code? Are you considering how you're developing the skills of your junior engineers? You can also build features that use AI, such as automatic content generators, and it's pretty easy to do, actually. But fine-tuning those prompts is tricky, and it takes a lot of manual effort to get it just right. And have you considered how you're going to keep those prompts up to date as the AI engines change out from under you? Have you thought about how you're going to tell when the AI engine has changed and your prompt has stopped working? This is all costs of maintenance. Ultimately, complexity comes from teams that prioritize building over maintaining, and the costs of doing so are devastating. Now let's look at another source of muda: slow feedback. Feedback loops are about how effectively developers can work. After an engineer makes a change, they have to check to see if that change did what they thought it was going to do. How long does that take? That's your feedback loop. If it takes less than about a second, they can check every single change, every line of code even. And this is what test-driven development is all about, and it's an amazing way to work. And let me show you what that looks like. I'm about to show you the full build for a real production system. And those of you who work with real production systems and watch the full build are probably wondering, how long are we going to be here? Now, this system that I'm about to show you is on the small side, but it is 12 years old, and so it's had the opportunity to accumulate some technical debt. So let's see how long the build takes. So it takes a moment to start it, and then that's it. Just over 8 seconds. That's the full integration build. For context, most organizations I meet are happy with a build that takes 8 minutes, not 8 seconds, and most are much, much slower. A big part of the reason this build is so fast, or rather why most builds are so slow, is the tests. Most teams have slow, brittle tests. This code base has over 1,300 tests, but they only take 2.5 seconds. Describing how to achieve these sorts of fast tests is a talk all on its own, but I do have a lot of material on this topic, and you can find it at jamesshore.com/s/nullables, or just follow this QR code link. 8 seconds is a nice, fast build, but it's actually still too slow, at least too slow for a great development experience. In a perfect world, we want engineers to be able to check their work at the speed of thought. If you can check every single line of code that you write as soon as you write it, finding bugs becomes easy. You make a change, you run the tests. If the tests fail, you know where your bug is. It's in the line of code you just wrote. There's no need to debug because the mistake's obvious. To get these kind of results, you need your build to be less than 5 seconds at the most, and preferably less than a second. And this isn't a fantasy. It is possible to do this with real production code. And I'm going to show you that happening right now. This is going to actually run the build 3 times. So every time you press save, boom, it runs the build. Save, run the build. It's less than a second each time the build runs. There are a few tricks here. First, the build automatically runs when the code is changed. Second, the build is written in a real programming language, so it's able to do things like keep track of which files are involved and how they relate to each other. So when it detects a change, it doesn't have to scan the whole file system again. And it only runs tests on the code that's changed. I have to be honest. Some of our code has these sorts of feedback loops. But for the systems with the most muda, it takes much longer than a second to get feedback. Sometimes it can take tens of minutes just to get the system in a state where we can run a manual test. So people don't check every change. They batch up their work, they test it all at once, and then they have to go through these long, tedious debugging sessions to find the cause of each error. And some errors aren't caught at all. That leads to muda. And that's why fast feedback loops are so important. A third issue that leads to muda is deferred maintenance. Deferred maintenance is really a consequence of the other 2 problems. If the system was simple, you could upgrade critical dependencies early. But most companies have a lot of complicated dependencies, and some of those updates require major re-architectures. Anybody tried to upgrade Rails, especially the older version? Similarly, if the feedback loops were fast, you could make changes quickly and safely. But most companies' feedback loops are slow, so making changes takes a long time. Major re-architectures plus slow changes means that upgrading dependencies can take weeks or months of effort. And so now you have to make tough prioritization decisions. Do we build an important new feature? Or do we upgrade a component for no visible benefit? Business partners often choose to defer the maintenance, and I don't blame them. But that deferred maintenance compounds, things get even more expensive to upgrade, and then eventually the bill comes due. The component is so outdated that you have to upgrade it at a time you don't really want to, and it can take months to get back to the point where systems are working cleanly again. So what do you do about such a difficult set of problems? Complexity, slow feedback loops, deferred maintenance. These problems are really common in my experience. Usually you hear people talking about legacy systems, technical debt, but whatever they call it, the underlying problem is the same: low internal quality, high muda. I've seen 4 approaches to fixing systems with low internal quality: Big Bang rewrite, modular rewrite, and change-driven rewrite, and improving in place. Be careful. The first 2 approaches are the most popular and also the ones that are most likely to fail. In a Big Bang rewrite, you start up a new team to write a new version of the software. Meanwhile, the old team keeps maintaining the software, adding features, fixing bugs, and so forth. And when the new software is done, the old software will be retired and the new software will take its place. In this slide, the old system is represented by the spaghetti in the top row, and the new system is represented by the clean, shiny dishes in the bottom row. That sounds nice in theory. But what really happens is the rewrite always takes longer than you expected. And meanwhile, the original software keeps getting bigger and bigger, and the mess gets worse, and worse because people are going to think it's going to be thrown away, so they stop putting as much work into it to keeping it clean. The replacement keeps taking longer than expected. You're spending twice as much money because you're running 2 teams, but you're not getting good results for your money. So the replacement is either canceled or it's rushed out the door. Customers are unhappy because it doesn't do everything the old system did, and your engineers are unhappy because in the rush to get the replacement out the door, they made a mess. It's better than the old system, but it's not that much better, and it's going to need another rewrite soon. In other words, big bang rewrites are dangerous and they should be avoided. Another option, not quite as common, is a modular rewrite. A modular rewrite takes a big existing system and identifies pieces that can be split off and rewritten. Then each piece is rewritten one at a time, and this might be done by a separate team, but sometimes it's done by the same team. Over time, the whole system is replaced without the risk of a big bang rewrite. But as always, things are harder than expected. You end up chipping away at the edges of the problem, but the big complicated core stays just as big and complicated as ever. And as always, other priorities intervene before you can finish. So now instead of having one complicated system, you have multiple complicated systems. They're all interfacing with each other in confusing ways. And if you're not careful, you can end up with a bigger, uglier mess than you started with. Modular rewrites are safer than big bang rewrites because they work in smaller pieces, but they suffer the same problem. Everything is bigger and more complicated than expected, and if you stop part way, you're left with a mess. The trick to a rewrite is to realize that you can never compete with features. Instead of establishing a rewrite team, continue with a single team. Instead of prioritizing rewrite work, continue to prioritize features and bug fixes. But whenever you make a change, migrate the code you're changing to the new system. Don't describe it as a rewrite. It's just part of the work you do to complete the new feature or the bug fix. That way you don't have to compete for budget. You don't have to justify the costs of the rewrite. You just do it as part of your normal work. This approach is slow. It will take years to complete. But thanks to the Pareto principle, that's the 80-20 rule that says 80% of the changes to the system will occur in 20% of the code, you don't have to rewrite everything to see a benefit. You do need to commit to seeing it through, but it's easier to do so when people aren't breathing down your neck asking when the rewrite will be done. In this approach, you don't add a new team. You can still add people if you want, but you add them to your existing team and use them to develop new features, migrating code to the new system as you go. But even better than a rewrite is not rewriting at all. Instead, improve your existing system in place. As you work on features and bug fixes, add tests, clean up your automated build, file off the rough edges. It will never be perfect, but the Pareto principle will kick in, and the parts of the system you work with most often will be the parts that you improve the most. Remember that 8-second build I showed you? That's a 12-year-old code base, and it wasn't always that smooth. 10 years ago, it was kind of a mess. It was never terrible, but it was definitely worse 10 years ago than it is today. Steady, consistent effort to improve it in place means that today it's a pleasure to work in and better than it's ever been. And 10 years from now, it will be even better. That is a beautiful place to be in, where the older the code is, the better it is. That's what you get from improving in place. So if you have internal quality problems, improve your existing systems in place. This takes specialized skills, so you might need to hire people for those skills. And personally, I hired a bunch of extreme programming coaches, and we're doing a lot of training. Sometimes you can improve in place, and that's true for us as well. If you want to change fundamental technologies, such as the programming language you're using or a core framework, programming framework that you're using, then you may not be able to improve your existing system. In that case, I would suggest doing a change-driven rewrite. That's what we're doing. We have tried the other approaches and we're worse off as a result. So migrate your code to the new system as part of your work on the old system. Modular and Big Bang rewrites actually can work, but they are dangerous. Modular rewrites risk leaving you with a bigger, uglier mess than you started with. Big Bang rewrites risk you leaving you with a half-baked product. I've seen more than one company do a Big Bang rewrite and now have two products they sell to customers. One that's easy to work with but doesn't do everything the customers want. One that customers want to use but doesn't work well. So although a modular rewrite and Big Bang rewrite can work, I don't recommend those approaches. If we were the best product engineering org in the world, our software would be easy to modify and maintain, we'd have no bugs, and we'd have no downtime. If only that were true. We are looking at three things. We are simplifying our technology stack. We're focusing on the cost of maintenance instead of the cost to build. We're improving our feedback loops. We're building systems that allow developers to check their work in less than 5 seconds, preferably less than a second, and we're introducing test-driven development. And we're no longer going to defer maintenance. When a dependency has a new version, we want to upgrade it immediately, without waiting. We don't want it to allow it to be a prioritization decision. We want to make it a requirement and stop the line until that upgrade is made. We're not there yet. But as our technology stack becomes simpler and our developer experience better, those upgrades will get easier. And for those existing systems where it's not as easy as we'd like, we're avoiding big rewrites. We're improving our systems in place where possible and undertaking change-driven rewrites where not. Jeff Patton is here this week. Hey, Jeff. He's giving tomorrow's keynote, and from previous experience, I can tell you that he is not to be missed. Jeff can tell you much more about making software that people love than I can. So what I'm going to do is I'm going to talk about how we make time to put Jeff's ideas into practice. So I just talked about internal quality and reducing muda. The better your software's internal quality, the faster your teams will go. So investments in internal quality are easy, as much as you can afford. The main challenge is managing your cash flow and balancing that investment with forward progress. Lovability is external quality. It's about building software that our users, buyers, and internal stakeholders love. So we're going to put all of our remaining capacity towards external quality. But there are always more ideas than time to build them all. So lovability is also about understanding what stakeholders truly need and putting our limited capacity towards what matters most. We can't have an agile talk without this diagram, right? People have understood this idea that we need to really focus our ideas where it matters for a very long time. And back in the days before Agile, companies would put immense amount of effort into requirements analysis in order to make sure they were building the right thing. They would analyze the market, define exactly what to build, and then build it. And those of you who weren't around in the 90s might think, this waterfall idea, it's not really real, it's just a fable. This is something that we make up to say how great Agile and Scrum is. Surely nobody really worked that way. But people did really work that way, and a lot of companies still do. They just call it Agile. They say they're Agile, but when you look at how they plan, what they actually do is analyze the market, decide exactly what to build, and then build it. The only difference is they don't make the requirements documents anymore. Instead, they make JIRAs. They chop up their requirements documents into lots of itty-bitty pieces, and they move those pieces around a lot. This approach is called project-based governance. You create a plan, and then you work the plan. If you execute the plan perfectly, coming in on time, on budget, and as specified, then you're going to be successful. At least that's the theory. Ryan Nelson wrote in CIO magazine back in 2006, projects that were found to meet all of the traditional criteria for success, time, budget, specifications, may still be failures in the end because they fail to appeal to the intended users, or because they ultimately fail to add much value to the business. Similarly, projects considered failures according to the traditional IT metrics may wind up being successes because despite cost, time, or specification problems, the system is loved by its target audience or provides unexpected value. One of my favorite stories about how this approach fails is the FBI's virtual case file system, and that's because there was a US Senate investigation. So we have lots and lots of documentation about what happened. It's unusual in how high profile it was, but the story is very typical of its time. In June 2001, the FBI launched the virtual case file project. 17 months later, they had established solid requirements. 17 months. They knew exactly what their users needed, or they thought they knew, and they had a detailed plan. And then a year later, the project was delivered, and it didn't work. The FBI immediately discovered a number of deficiencies in VCF that made it unusable. That's a quote from the Senate investigation. In 2005, the project was officially canceled, and the director of the FBI appeared before the Senate to explain how the FBI had managed to waste $104.5 million of taxpayers' money. The problem wasn't that the software didn't function. The problem was that all that detailed planning resulted in building the wrong thing. The software didn't meet the FBI's needs. And before you say, well, that was then, but we're agile now, look at this list again. How does your company manage projects? Do they define success as delivering on time, on budget, as specified? Do they ask you to prepare a plan, then track progress against that plan? The problem with this approach is that we can't predict what our customers and users really want. We can only guess. Some of those guesses are right, and some are wrong. We have to conduct experiments to find out which ones are really worth pursuing. One of my favorite expressions of this idea is Eric Evans' build, measure, learn loop. We have an idea about what customers might love. We build a simple experiment that lets us test that idea, the smallest, simplest experiment we can think of. It might not even be code. It might just be interviews, surveys, or Figma prototypes. Then we conduct the experiment and see what data comes out of it. We learn from that data, and that improves our ideas of what we should build next. This loop is where the idea of minimum viable product came from. Have you all heard of minimum viable product? But minimum viable product is often misunderstood. Minimum viable product isn't the smallest thing we can deliver to customers. It's the smallest test we can perform to learn what we're going to deliver to customers. Those tests can be very small because the faster we get through this loop, the more we can learn and the less time we can waste on failed ideas. This leads to product-based governance. Rather than creating a plan and working the plan, we iterate on a series of very small plans. If we learn and change our plans, we can steer our way to success. Success means delighting our stakeholders and doing so in a way that impacts the business. We aren't tracking adherence to plan, but instead return on investment. Adapting plans is one of the key ideas of Agile, of course, and Martin Fowler describes the essence of Agile this way. Agile development is adaptive rather than predictive and people-oriented rather than process-oriented. So, now that Agile has taken over the world and just about everybody's using some flavor of Scrum or SAFe or something else, we're all able to adapt our plans, right? I'd like to say that's true, but we know it's not true, don't we? There are a lot of companies that say they are agile or do Scrum, and they're not either of these things. They're predictive rather than adaptive, and they focus on process rather than people. And if you're not adaptive, if you're not people-oriented, you're not agile. No matter how many Scrum Masters, sprints, stand-ups, stories, or Jira tickets that you might have. The build, measure, learn loop and adapting your plans is important at a tactical level. But what about big picture strategy? At my company, strategy is decided by our leadership team, which consists of our CEO and heads of product, marketing, sales, partners, content, finance, and so forth. Alignment at this level is critical. Each person has their own view of the world and their own theories about what's needed for the business to be successful. Product wants to improve usability. Marketing and sales want splashy new features. Finance wants to reduce manual billing. Each person has their own view of the world and their own theories about what's needed for success. So how do you balance those competing concerns? How do you allocate engineering's limited capacity? We're trying something called product bets. A product bet is a big picture hypothesis. For example, our head of sales might say, a lot of our customers are vampires. We can close a lot more deals if we introduce an AI-powered salesperson that's available at night. And plus, the board loves AI. Now, I'm going to tell you a secret. I can't tell you what's really going on in our company, so our customers are not actually vampires. They might be werewolves. Product bets are proposed with a short one-page summary of the hypothesis. It has a thesis statement. Increase vampire sales with an AI-powered night salesperson. It has a sponsor, the head of sales. It has the value we expect to gain, which is typically linked to a spreadsheet with a financial model. And it has a summary of the reasoning for the value. In this case, vampires spend $80 million on services like ours. Many of them use their human servants to buy things. But if we sell to them directly, they'll be more likely to buy, and thus will increase our market share among vampires by at least 1%, resulting in $800,000 yearly in new sales. And then finally, there's a wager, which is the maximum amount of money we're willing to spend on this bet. Other members of the leadership team have their own priorities and bets, so naturally they're going to come up with objections. The head of content might say, shopping is beneath vampires. That's what they have human servants for. The head of marketing might say, AI isn't good enough to do sales. The head of finance might say, that's going to cost a lot more than $400,000. They all have their own pet projects that they want, so they're going to find reasons not to do this one. And we want those objections. We want an open and honest dialogue between members of our leadership team, picking holes in the bets and finding ways to make them stronger. Ultimately, if a bet is chosen, those objections lead to experiments that we can test in the build, measure, learn loop. Shopping is beneath vampires? Let's find out. So our hypothesis is that vampires will actually feel appreciated by us having vampire-friendly hours. We want to test that hypothesis as quickly and cheaply as possible. So we don't build software. We build by temporarily moving some salespeople to a night shift. And then we measure the difference in vampire sales. And let's say we got 5 times as many sales. We've learned that yes, there is a market for vampire sales at night. So our next objection is that AI isn't good enough to do those sales. So our hypothesis is that no, actually, it's not going to be as good, but it's going to be good enough. And again, we want to test that hypothesis with the minimum effort possible. So we still don't build software. We build a custom prompt in ChatGPT that the human night shift is going to use. And some of those salespeople use ChatGPT and follow the script, and others continue as they were, and we measure the difference. And in this case, let's say the sales decreased from 5 times as many to 2 times as many. So what did we learn? A night shift is a great idea, but AI-driven sales isn't. So we change our plans. We decide to build a permanent human night shift instead of using AI. And now we've saved nearly $400,000. We spent a little bit of time and money on bonuses for the salespeople who participated in the night shift. We spent some money on the custom ChatGPT prompt, but we spent much less than we would have spent building the entire software solution. Ultimately, we want our leadership team to align around strategy, and product bets are a tool for doing so. Now, I have to be honest, getting adoption on this idea has been very slow, and we're still rolling it out. So of all the things I'm presenting today, this is the one that's the most experimental. However, I do have the very strong support of my CEO. It's just the rest of the leadership team that thinks this is going to be a lot of work. So this is the one to be most careful about adopting yourselves. But if it works out, it's not going to be just a tool for strategic prioritization. It's also going to be a tool for leadership to think critically about their ideas and a way to generate hypotheses for us to test using the build, measure, learn loop. If we were the best product engineering organization in the world, our users, customers, and internal consumers would love our products. But even more, we would understand what our stakeholders need and put our limited capacity where it matters most. First, we need to achieve strategic alignment at the leadership level. We're starting to use product bets for that. They're not just for prioritization, though. They're also a way to think critically about our plans and generate hypotheses that we can test. And second, we need to validate those bets and adapt our plans based on what we learn. We're using product-based governance that focuses on impact rather than adherence to plan. And we're using the build, measure, learn loop to test our hypotheses as quickly and cheaply as possible, preferably without building software at all until we've proven out our ideas. Given limited capacity, and there is always limited capacity, there will be winners and losers in the prioritization game. Some people will be happy about the amount of time they're getting from engineering, and some will be sad, even angry. Transparency is vital for building trust with internal stakeholders. Where are we spending our time and why? We send out regular reports, but that isn't enough. We also have to talk to people, understand their perspective, and share what's going on and why. And even if you do all that, there will still be people who are unhappy. As we say in the US, you can't please all the people all the time. I have to admit, I don't have good answers about how to build trust. I chose the company I'm in now because I already had their trust. I'd worked with their founders before, 15 years ago. They knew what they were getting, and they wanted what I had to offer. Even so, the founders' trust didn't automatically extend to the rest of the leadership team. A lot has changed in 15 years, and nobody else knew me. In fact, what the founders and I wanted, and what the rest of leadership wanted, wasn't in alignment. We wanted product-based governance in the build, measure, learn loop. They want predictability. The way they judge trustworthiness is simple, very simple. Was engineering doing what they said they would do? In other words, did we ship on time? And the answer was no. Engineering was not shipping on time. There are a lot of reasons engineering wasn't shipping on time. We didn't have a good approach to forecasting to begin with, but even if we did, predictability wasn't something I was planning to focus on. Predictability is the realm of project-based governance, and I was planning to introduce product-based governance. product-based governance can be very frustrating for people who want predictability because we don't know what we're going to do here until we know what happened here. We can predict how long it will take us to get through one loop, but we can't predict what the rest of the loop, or what the next loop is going to look like. Well, we could, but that would mean we didn't learn anything. And if we didn't learn anything, we're not producing as much value as we could. So, as another classic American saying has it, the only winning move is not to play. How about a nice game of chess? One of the first things I did after joining the company was introduce a more rigorous approach to forecasting. This approach requires gathering a lot of data, and while that was happening, I told my teams to stop making predictions to stakeholders. That did not lead to people loving me. It's not that they needed the predictions for any purpose. Predictions were being used as a political weapon. You promised this would be done. Well, the leadership team decided that we should work on this other thing instead. It doesn't matter. You promised this would be done on this date, and it wasn't, and this is more important to me than what the leadership team said. In other words, predictions were causing more harm than good. So the new forecasting approach is in place now, but we're still not providing dates. Instead, we're providing time ranges. Historically, a valuable increment of this size has taken between 2 and 6 weeks. But we're still not predicting dates because we don't know when the work's going to start. As an example, one of my stakeholders has a project that's very important to him, and it keeps getting delayed by other priorities, and he's upset about that. So he asks me, when will it be done? And I say, 2 to 6 weeks after we start. And he says, okay, so when will it start? And I say, when it's prioritized by the leadership team. We're ready to start as soon as they say go. He is still unhappy. But now he is unhappy with the prioritization process, and he's putting his effort into influencing prioritization decisions, which I'm going to call a win. People really, really, really want date predictions. The reason I can get away with not providing them is because the CEO, CTO, and Chief Product Officer are on my side. They are the founders of this company. They understand the value of adaptive planning, and they trust my leadership. And it's the reason I'm working there. I was a consultant for 23 years prior to joining this company, as I said, and I was looking for a company to join for 5 years prior to joining this one. There's only so much you can do as a consultant, and I wanted to be in a place where I could have longer-term impact. It was very hard to find a place where I thought that I would get the support I needed. The reason I chose this company was because I knew I would get this level of support. One way the CEO is supporting me is that he invited me to give a presentation about Agile at one of our quarterly leadership retreats. It's normal for me to attend these events. They last about 3 days. But for this one, I was given 4 hours out of that schedule to use as I wish to explain Agile ideas. And that's a really substantial amount of time. I used the time to explain Muda and the reasons for our capacity constraints. I talked about product-based governance and many of the things we've discussed today. And most importantly, I had them sit down and play a game. In that game, which is called the Agile Fluency Game, participants experience exactly what it's like, or participants experience what it's like to be part of a team that's adopting Agile for the first time. There are a lot of different lessons in the game, but the biggest one is the cost of maintenance. If you aren't careful about managing your maintenance costs, you'll go out of business. And before you do, you'll have several uncomfortable rounds struggling to make progress while all your spare capacity is being put towards Muda. In other words, it was exactly the problem we're facing. That opportunity turned things around for me at the company. I wouldn't say I have everyone's trust yet, but I do have their respect and understanding. They understand why engineering isn't giving them what they want. They understand why we're focused on adapting our plans, and they respect my ability to improve it, or at least they respect the founder's trust in me. I still have a long way to go. In 2025, we're putting more emphasis on product bets and strategic planning. And as part of that work, I'll be working with the leadership team to create financial models of the costs and benefits of each of those bets. I'll be providing forecasts of the capacity available in each of our product collectives and helping stakeholders understand how their prioritization decisions result in trade-offs in engineering capacity. I'm hoping that working together in this way will help us further develop the visibility and trust that we need, but it is a long, slow process. But without trust, we can't be successful. So if we were the best product engineering organization in the world, our internal stakeholders would trust our decisions. I don't think we're there yet. Most of that comes down to unhappiness with our capacity and with prioritization decisions. And to be honest, I'm no political genius. Somebody who's more clever than me can probably figure out a better way to build the trust that we need. For me, though, it started out with having champions in the organization who already trusted me, being transparent about our capacity challenges, and showing people why things were operating the way they were with a hands-on experience. But at the same time, I'm staying true to our goals. People always want predictive rather than adaptive approaches. And I'm holding firm on staying adaptive. I'm providing forecasts, but I'm doing it by extrapolating from historical data that compares estimates to actual results, and even then, I'm only forecasting how long things will take once they've started. I'm not providing dates. This is what's working for me. Your situation is going to be very different, and so I'm not suggesting that you follow this approach exactly, or really even at all. For example, if your CEO doesn't support adaptive planning in the way mine does, then you might need to make predictions. In fact, you probably do need to make predictions. So please adapt these plans for your situation. If we're going to adapt our plans and follow that build, measure, learn loop, we need the technical ability to do so. And there are two aspects to this, tactical and strategic. From a tactical perspective, most engineers that I meet don't know how to design software incrementally. Most software development education comes from a waterfall perspective, which assumes time spent on analysis and design before coding. If you break up that work into short sprints, you're going to create, by default, engineers will create mini waterfalls, where they do a little bit of planning, a little bit of design, a little bit of programming, and a little bit of testing. They won't have enough time to do the testing and design work that they really need to do, so they'll struggle to create a cohesive design, and they'll struggle with bugs. If you adapt your plans frequently, as you should, it becomes even harder. Your internal quality will suffer, and Muda will rise. To be successful in an adaptive environment, you have to keep your design and code clean at all times. And extreme programming practices such as evolutionary design, merciless refactoring, and test-driven development allow you to test, code, and design simultaneously, so you always have enough time for design and testing, even if you're using short sprints. In other words, before you can have business agility, you need to have technical agility. And this is where extreme programming shines. And it's why I'm hiring for XP skills at my company. There's also a strategic component to supporting business agility. As our business strategy changes, the amount of investment we put into this product or that product changes. Our ability to respond to these changes depends on how we organize our teams. The classic way to organize software teams is functionally. You've got a front-end team, a back-end team, a database team, and I think we all know the problems that this causes by now. In order to deliver any value, we have to coordinate all three teams, or all four teams, and it leads to delay and errors. Muda. Agile teams are cross-functional. We create teams that can own an entire portion of a product. Product and front end and back end and database and operations and security. We could call it BizDevSec Data Kitchen Sink Ops. In theory. In practice, it's hard to fit that many people into a single team. So we end up having to divide people amongst teams, and the most popular book on this subject is Team Topologies. Team Topologies provides ways of organizing teams so you can keep them small, 7 or so people in each team, while still keeping them autonomous and focused on delivering on value. We have stream-aligned teams, which is what we really want because they're the ones that are focusing on the value streams. And then we have enabling teams, complicated subsystem teams, and platform teams as a way of working around the fact that we can't really have what we want with such small teams. So if we have too many people for one team, we divide them into multiple teams. For example, let's say we're at a company with 4 products. The legacy moneymaker, a big bet on the future, a way of expanding into new markets, and a bet on the far future. And we can create a stream-aligned team for each product. But we have a problem here because some of these teams are still way too big. Team Topology says we can split these teams up further, and depending on how you design the teams, that can work pretty well. I've used this approach many times myself. But over time, I've found several problems with the Team Topologies approach. First, everyone is so isolated to their teams, silos form. And in my experience, people barely interact across teams, even in the same product. That makes it difficult to succeed across team initiatives, and it's hard to move people between teams. Second, teams are rigid. When business needs change, adding and removing people from teams is a problem. Because teams are limited in size, new business needs often require you to reorganize your teams, which is a huge disruption. Often, engineering resists the reorg, leaving their business partners frustrated because effort isn't being spent where they want it to be spent. And then third, specialties such as user experience, security, and operations are often spread too thin. You don't need a full-time UX designer on every team, for example, but having people work part-time across multiple teams doesn't work very well either. It leads to constant task switching and makes it difficult for people to focus, and it wastes a lot of time. And then finally, the teams often aren't really independent, especially when you have a legacy code base. It has to be shared across multiple teams, and no team really wants to own that legacy code base, so quality degrades further as people focus on the code that they do own. So to solve these problems, we need to build in another direction. We need to build up, not out. When people think about adding a lot of people to an engineering team, they usually think about adding more small teams. But that's just one way to scale. That's horizontal scaling. You can also make teams bigger. That's vertical scaling. Vertical scaling allows you to remove the complexities of team topologies and return to one value stream per product. And my favorite way to do this is an approach called FAST. FAST was invented by Quentin Quartel. It stands for Fluid Scaling Technology, and you can learn more at fastagile.io. I have several in-depth presentations on my website, which you can find by following that QR code. And there's also a session at FAST at this conference later today. Yoshiki Iida and Takeo Imai will be speaking in room C at 3:15. And apologies if I pronounced those names wrong. So here's how FAST works. First, everybody gathers together in a big room or online. All the teams I've used FAST with have been fully remote. So we used a video conference in Miro, which is a whiteboarding tool. The meeting starts with announcements, and then team leaders from the previous cycle, who are called team stewards, you may remember them from the discussion about people, they describe what their teams have worked on since the last FAST meeting, just 2 to 3 days ago. Next, product leaders describe their business priorities. That's up there on the right. And on your whiteboard, you'll have a set of high-level business priorities. My teams work in terms of valuable increments, which are things that we can release that add value to the organization. You can see that some increments are in progress, these 4 in the upper right, and some are waiting to be started. When the product leads describe their business priorities, they're going to describe how those priorities have changed. And usually it's a quick no change. But sometimes some things have changed, and the product managers explain what's changed and why. Next, team members volunteer to steward a team. Remember, this is something that the more junior engineers are expected to volunteer for, not just the senior engineers. Anybody can steward a team. Most teams are stewarded by engineers, and the maximum number of stewards is limited to ensure that each team has about 3 to 5 people in it. Each steward describes what their team is going to work on. The stewards are expected to work on something that provides value to the business, but they use their own judgment about what that is. Most of the time, it's going to be feature work, but it can be things like improving the build or cleaning up noisy logs. Usually, it's just we're continuing what we worked on in the previous cycle. Finally, people self-select onto the teams based on what they want to work on, what they want to learn, who they want to work with, and ultimately, what's going to provide the most value to the business. Most of the time, people continue with the same team that they were with in the previous cycle. And that's it. That's the FAST meeting. It takes 10 to 20 minutes, and it's really all there is to FAST. It's a way of having a single large group of people work together collectively by dynamically breaking into teams every few days. It's simple, it's fast, and it's effective. FAST completely solves the issues I've seen with team topologies. I've actually stopped using team topologies in favor of just having large product teams. First, when you have small teams, it's hard to plan work that involves multiple teams. With FAST, you have larger teams, so cross-team initiatives are much less likely because everybody's together that needs to work together. We haven't had any at my company since we started using FAST over a year ago. Second, team topologies has trouble with big business priority changes. That's not a problem with FAST because the F stands for fluid, and it's really true. People dynamically adjust to whatever the business needs. It's incredibly responsive as well. If there's an urgent need, we bring it to the next FAST meeting. There's 2 a week, and people form a team around it and go. We just have to be careful about managing priorities and minimizing work in progress. I am constantly reminding my product managers that it's better to finish work than to start work. And then third, when you have small teams, specialists get spread real thin across multiple teams, which leads to frustration and task switching. And that isn't an issue with FAST because the collectives are large enough that each one can have a dedicated specialist. They self-select into whatever work needs to be done. So we had 3 user experience designers at my company that were spread across 8 teams. Now each collective just has 1 dedicated UX designer assigned to them. And finally, shared code is no longer an issue because you can combine the teams that share code into a single collective. FAST isn't perfect, and there are some challenges with moving to FAST that I don't have time to go over today. So if you're interested in coming and trying it, come talk to me. I'll be sitting out somewhere and love to talk to people. Or you can watch my presentations about it. I haven't seen anything that's better for solving organizational problems that occur at scale in engineering organizations. Even though it's not perfect, it is the best approach to large-scale agile development that I've yet seen. So if we were the best product engineering organization in the world, we would seek out opportunities to change our plans. We'd work in small pieces and adjust our strategy based on what we learned. And to do that, we not only need the business agility we've already discussed, we need technical agility. Specifically, we need extreme programming practices, which allow us to change direction without creating a technical mess. And we need FAST, which allows teams to shift fluidly in response to changing business needs. Profitability is last on the list for a reason. If we take care of our people, if we take care of our internal quality, if we take care of our customers and our users, if we take care of our internal stakeholders, if we're responsive to changes in the market, we will be profitable. Almost. we have to remember that the only way we can take care of our people, our customers, our users, and everyone else is if we stay in business. It's not enough to build great software. We also have to build it to be sold, to be cost effective, and to be put into production. There's a funny paradox about engineering. Great engineering doesn't seem to be heavily correlated with business success. In my career as a consultant, I met a lot of companies with, they were really struggling from an engineering perspective. But they were still very successful from a business perspective. And that's because no matter how much of a mess they were under the covers, they served the needs of the business. Here are a bunch of departments you might see in a business-to-business product company. Each of them directly contribute to the company's yearly revenue. Marketing generates leads, the people who might want to buy your software, and they do so for your sales department, and they're judged on the number of qualifying leads that they create. Partners also generate leads, or even sales, from people who are using complementary software to yours, people who are not your competitors, but that have customers that you might share. Partners is judged on the revenue that those partners generate. Sales converts leads into paying customers. They're judged on the new revenue that they generate. Customer success takes care of your customers. They're judged on customer retention and upsell rates. So what does product engineering do? Our job is to create new opportunities. Let's say that the trajectory of your company is to grow its annual revenue by, let's say, $10 million a year. Our job in product engineering is to increase that rate of growth from 10 million to 12 million a year, or 15 or 20 million a year. Every time we ship a new feature, we should be increasing the rate of growth of the company. Our features should open up new markets, allowing marketing to generate new leads. We should provide useful APIs, allowing partners to build new relationships. We should be responsive to market trends, allowing sales to convert more leads. And we should fix the problems that get in customers away, reducing churn and improving upsell. Every dollar invested into engineering should be reflected in permanent improvements to the value your company creates. It may not be dollars or yen, it may be helping to cure malaria or solving climate change, but however you define value, the purpose of product engineering is to change the trajectory of the company for the better. If we were the best product engineering organization in the world, we would build our products to be sold. We would work closely with our internal stakeholders to ensure our products were ready for the real world of sales, marketing, content, support, partners, accounting, and every other aspect of our business. We would plan for observability and operability, for outages and data security. We would build software that changes the trajectory of our business. And we would do it by having the best people in the business, having such high internal quality that changes were easy and bugs were rare, focusing our effort on the changes that would make the most difference for our users and stakeholders, having the trust of our internal stakeholders, and seeking out new opportunities and adapting our strategy. Are we the best product engineering company in the world? No, we're not. But we would like to be, and we're never going to stop improving. I hope these ideas will help your companies improve as well. Thank you for listening.
Thank you for great talk. ではご質問あったら any questions in this room? Okay. Thank you. Thank you.
So I have two questions, really. One is the timing. It seems to coincide with the release of the McKinsey paper about developer productivity. So I wonder if there was any trigger from your CEO to ask about developer productivity regarding that McKinsey paper?
I don't think so.
Okay.
I haven't heard of the paper myself. I think it was triggered by some business factors that are causing us to focus on efficiency.
All right, yeah, makes a lot of sense. The other question I have is, so I understand the career ladder, but that very closely ties into compensations and promotion. So I was curious how you manage those questions that arise from having such a very clear, defined criteria for all those different roles.
Yes, so we didn't change compensation, but we did change the definition of roles. Which meant that some people were in roles that they were no longer qualified for based on the new criteria. And we are not demoting people and we're not firing people. So we're giving people time to sort of adapt to the new requirements.
Right. And can you shed maybe a little light on how you approach compensation? Is that done by an individual or is that more like of a collective process? Because it's typically one of the hardest things to get right.
Yeah. I didn't change the way we do compensation. We practice salary transparency, which means everybody with the same title has the same salary. And actually, I believe we are about to start publicizing that internally. So you can see what every title salary corresponds to.
All right, thanks a lot.
And I know I went a little bit long on the talk, so if we don't have time for questions, I'm very happy to take questions out in the hall.
We are very flexible. No problem, I think. じゃあちょっと他の部屋、any question from the online or other rooms? これ筑後にするんだっけ？筑後にする。じゃあ筑後通訳になるそうなので、日本語で喋っていただいても大丈夫だそうです。Any question? Please come here. Thank you.
Hi, this is a very quick one. Is, in your opinion, Scrum or extreme programming are either or decision? So can you use stream programming in Scrum teams, in your opinion?
Oh, absolutely. Extreme programming is mostly a superset of Scrum, I would say. The major addition of extreme programming over Scrum is the technical practices, and originally that it was a shorter iteration length from a month down to 3 weeks, and these days down to 1 week. But yeah, they're absolutely compatible, and sometimes I describe it as the agile technical practices, which you don't really find in any method other than extreme programming.
Okay. Good, thank you. I agree with you.
Hi, thank you very much for your great talk. I have a question about the improvement in place you mentioned in middle of the talk. I still don't imagine how it works. And for example, if there is some issue we found in the architecture, like a spaghetti code, where this code is related to this code, which is totally separated place, and then in order to improve this, you actually need to rewrite certain structure of the code. In this case, like we definitely need to rewrite some code. So I still couldn't get how the improvement in place work.
Yeah. Yeah, so the question is about improving, instead of rewriting, improving code in place. It's a challenging problem, and it can take a long time, and sometimes it's better to do a change-driven rewrite rather than improving in place. Generally speaking, the approach I take to improving in place is first improve the developer feedback loops so that we can run tests in a timely manner. Second, get as many tests in place as we can. Michael Feathers was here last year, it sounds like, so you probably heard this from him, but it's very difficult to make changes safely without good tests in place. Now there are a lot of strategies for that. You can do unit testing and integration testing, but you can also do pinning tests, which are sort of high-level throwaway tests that sort of define how the system works, including all its bugs today, so that you can make those bigger cross-cutting changes. And then once you have the tests in place that allow you to make changes safely, then you refactor. And it is possible to make architectural refactorings across the system, but it requires a lot of testing in place to do that safely.
I see. So it's more like detect the issue in the early hand so that you don't need to do that in the later stage of the...
That would be nice,
Okay.
but not true for most people.
Yeah, I think so. Okay, thank you very much.
Yeah, thank you.
オンラインの方、声出ししていただいて大丈夫なので、any question from online or other rooms? オンラインの方、先にもしあればどうぞ。大丈夫ですかね。
My name is Eric. First of all, thank you very much for the presentation. It's very inspiring. I'm particularly one particular idea or experience you shared caught my attention, which is the fast scaling techniques. And I think it kind of, I have a very similar situation in my company currently, and I was thinking about, okay, maybe we should try this year, where a multiple team was working on a single product. So there's a lot of hurdle last year. So I want to ask you, because I checked the link a little bit, I think you gave several talks like 2 years early already on this, and probably have accumulated quite some experience. I want to ask, over these several years of trying this fast techniques, is there anything that you see that this fast has problem with this particular type of team structure, or people, you know, I don't know, with people or with resource or whatnot, that this fast does not work so well in this kind of environment? I just want to hear some sharing.
Yeah, that's a great question. So as I mentioned in the talk, there's definitely challenges introducing fast. And the biggest challenge that I've seen now, I've introduced it at 2 different companies. In both cases, the size of the largest collective was less than 40 people. It scales to at least 65 people on a single collective, and theoretically goes all the way up to Dunbar's number, which is 150 people. But I don't think anybody has done more than 65 so far. What I found in both companies where I've introduced FAST, and both companies, it went on, the one I'm at now, it's been going for over a year, and the previous one, it went for about a year before they had a big picture reorganization. The thing that I found most challenging has been that FAST is ultimately a team-oriented environment, and in both cases, people would say they were part of a team, but what they really wanted to do was work individually. And that's why we put so much emphasis on teamwork in the career ladder that we talked about. So if you have an environment where people are used to so at my company, it was collaborative in that there was a set of stories in JIRA, and people would volunteer to take a story. There'd be something called the epic champion. It would take an epic, go off, figure out the design for that, come back, have it broken down into stories, present it, and then people would take stories, and then the epic champion would tell them how it all fits together. But each of those individual people working on stories would work on it independently. So it was, in English, there is a term called parallel play. When you have 2 babies playing together, they don't play together, they each play separately, next to each other. And that's what we had, parallel play. People were working independently next to each other, not together. What I've found is that when you use FAST and you ask people to join into teams and doing mobbing or something else, they're really working together. It's for the first time for a lot of them. And they find that very hard and distressing, because now they can't just work on their own and figure out problems. They have to be vulnerable and say, I don't understand how to do this. Please help me. That people are seeing the mistakes that they're making. And so we had a lot of reactions around, I feel micromanaged, even though we weren't actually observing what they were doing. I don't know how to work with folks. And we also had a problem with people changing teams too often, feeling like they had to be too responsive to business needs rather than focusing and getting things done. So I could talk a lot, and please come talk to me afterwards if you're interested in FAST. There's certainly challenges associated, but I still haven't found any better way of organizing large groups of people working on a single product.
Okay, thank you very much.
Mm-hmm.
Okay, this is enough time to have a question. Yeah, this is a great talk and a great question and answer. Thank you so much.
Thank you.
Thank you. ありがとうございました。Thank you.